So we are working on OpenRSP. It's an open source remote SIM provisioning protocol, which is involved in getting an eSIM or SIM card. When you get an eSIM or a SIM card, this is the RSP is the traditional protocol which runs and creates a profile and then delivers to your mobile device and then authenticates the profile, and later you can install and activate the profile. So we are building an open source remote SIM provisioning, and there are lots of improvements in that, but right now we are focusing only on the trust which it uses in the protocol, which is a chain of trust, and using certificates. The certificates they use is 509, X509, and these are entities and they need to share certificates for authentication and following operations. So they have a structure of trees. We decided to just create a root node of the certificate authority, and then later all the entities which does different operations are the leaf nodes, so that all the entities become a prover. They can prove that they hold a valid certificate, and the central authority will be a verifier, and it will verify the authentication. So that, for example, if someone creates a SMTP server, and let's say AIS created their SMTP server, they verified a few profiles. Then like DTAG can also use those authentication, and they don't need to like verify again. They can verify again, but it can be reusable, which is not right now. So it can be useful. And there's a lot about X509 certificates. It's basically a standard introduced and used in International Telecommunication Union. The important part is it is used in TLS. It is based on ECDSA and different RSA, DSA supports. The main important thing is it assumes also a strict hierarchical system of certificates. So they designed this because the feature of X509 also. So we won't focus on the certificates because we will focus on our architecture. So we will have a verifier, we will have a prover. Provers will be the entity, verifier will be the GNCI. We will have and that verifier will be like on-chain verifier, and there will be a central proof registry which will be maintained on-chain, and it will create basically all the proofs of different certificates that can be used. Yeah, and proof generations, we have certificate contains a lot of details, but we need to like hide a few details and prove only validity part of it. So we will pick up only few parameters. So it is like we will be proving all the time the same certificates, but different parameters for different interactions. So we will look into the zkCX systems as we want to inherit some zero knowledge properties as much as we can. So this is a basic chart. Since I said like we will be using the same certificates, so it should be something like same proof size. So to continuously verify all the proofs, stars are better, but we will probably focus on smarts right now. We have to create setup, but we will see either prompt or drop will suit fit. So we will, if prompt, we will have a universal setup. If groth, every circuit it will have a setup. Since we want fast and very fast, and proof size we want small or very small, so we will either follow it with this criteria. And this is just a chart to basic comparison, not much. So we think about using Node, and it's not decided yet, but yeah, let's see. Little about Node. It's like it's a zk programming language. The main tool it provides is that it have like for developers it have a lot of tools including merger proofs, ECDSA, field method, and more. So that if you write in Rust, you need to like use different traits, but rather it would be easier in here, and it doesn't compile the circuit directly. It compiles the circuit into a format this, and all the codes eventually get formatted to R1CS. So we have like flexibility using the proving system. So like we can use either prompt, either growth, and different smarts. So and design setup, circuit setup, we need to define inputs, we need to define the proving logic, and we need to prove generation and verification. So far we have just touched define the inputs because we were looking into the certificates parameter. So these will be the main inputs and these will be private input to ensure the confidentiality. But we are not sure. These things are flexible for us now as we are just on the design and the initial setup part, so it might change. But these will be definitely there, maybe a few more. So yeah, this is mainly everything for us. You can check out the repo. We have. It would be really good if everyone will check out the repo because it's like we have different segments right now. We have like trust, and then we have like privacy we need to focus on. We have divided our README also in different segments. Like on the bottom you can see. So like trust, we are working on certificates. For privacy, it's like there is a sensitive information called EID. When you get a SIM or anything, you share this information. It's like unique for every mobile device, and the host and the servers or the telco providers, yeah, they need this. So what happens is that EID is getting shared, and we cannot achieve this with zero knowledge proofs because it's like a big, maybe, yeah, it's a big integer and like a few bits. They need a few bits to identify your mobile device. So we cannot like use zero knowledge proofs here, and we need some experts to look into this because we need to transfer the bits to identify the chip where the profile is going to be. So yeah, if anyone check out, and we are working on this certificate, but we need like consistent a few inputs and work in over here and discussions also. So yeah, that would be awesome for us. Okay, that was all.